Okay, hello everybody. So this is our review video for rational functions test, which will be taking place later this week and or next week, depending on if you are on my A-day or B-day schedule. So this was our trash football game that we played in class, and this is the review video to go along with it. Now I kind of reordered it so that I kind of did all of the problems that are similar together. So I've kind of reordered um, the the slides a little bit just to kind of make sure it's just topic by topic and not just jumping around. So we're going to start with what we started with right after spring break, which was when we were talking about varying inversely. Okay, so when I say the phrase y varies inversely to x, this is a really small highlighter. What that means is I have some equation y is equal to some constant, again, a is just a number, over x. Okay, and this question is asking me, it's asking me to solve for y when x is 6. So, but first, I got to figure out what a is. I don't know what a is. It's a number, but that's all I know. So, using the information given, I'm going to solve for a. So I know that y is -7. So I'm going to plug that into my equation for y. So I have -7 is equal to, I still have no idea what a is. It's, again, still a number, but I don't know what it is. But I know that x is 3. So I can use that to plug that in. So now I know, okay, I got to get that 3 out of the denominator. We multiply by 3 on both sides. So now I get a is equal to -21. Okay, but that's not what the question's asking me for. My question is asking me for y, not a. I don't care about a. I need a to help me figure out what my problem is, but I got to figure out what y is. So we plug that a back into our equation. So our equation now becomes y is equal to -21 divided by my x. Okay, so still not what I was asking for. That was what the bonus question for this question was asking for. It's asking for this equation, but it's asking me for when x is 6. So what I'm going to do is I'm going to plug in 6 for that x. So I'm trying to figure out what y is. I now know what a is, and then I plug in that 6 for my x. Okay, so this is your final answer unless you want to simplify, which, hint, hint, wink, wink, you will probably have to do on the test. We can divide both of these by 3, so we get -7/2 as our answer for that. So that's all we mean when we're talking about something varying inversely to another thing. Okay, we usually need to figure out what this constant is, this a value, and then we solve from there. Okay, and again, the bonus part of this question, if you got it, was can we write the equation? The equation, again, is just this piece. I want two things. I want to relate x and y, but I need that a value to have a full equation. I can't have 3 unknowns in one equation because that's just bad. So we don't want that. We want something relating just x and y, okay? So that's what I mean when I say I want an equation as well. All right, so moving on to the next equation, or the next problem, it's the same kind of thing. Okay, so we have y is equal to a over x. That's what varying inversely means. That's what this first phrase means. Okay, but it's asking me solve for y when x is 2. I need a to be able to do that. So I got to use the information that I'm given to solve for a. So I know y is 3. I still don't know a, but I know x is 8. So now I can say, hey, a is 24 because 3 times 8 is 24. So now my equation, again, bonus part of this question, was 24 over x. I plug in that a value and I'm relating x and y. All right, but still not the final answer. I got to plug in x is 2. So I get y is equal to 24 divided by 2, which simplifies down to 12. Excuse me. Okay, so that would be our final answer there. Okay, so again, this is an equation. So if I ask you for an equation on your test, hint, hint, wink, wink, this is something what I want. If I'm asking you for a value of y when x is some sort of number, I want a number. Okay, so that's what I mean by those two things. Okay, so those are the only two questions when we're talking about varying inversely for our review game. But now we're going to talk about something we also talked about very soon after spring break, which was kind of how we graph rational functions and using more often than not this type of equation. Okay, I had y'all, when we were graphing, I had y'all identify h and k. Okay, h will always be attached to wherever the x is. So h is down here. But what is important to know, per usual with x's are always weird, their signs will flip. So h in this case is positive 5, not the negative 5 that's down here. It is positive 5. Okay, but k acts normal because it's normal. Y's are usually normal. Okay, so we have k is 7. And that's all it is to it. Okay, but when we were doing this in our notes, we kind of took it a step further, and that was the bonus part of these two questions when we were doing our review game, is where were the horizontal and vertical asymptotes? And those were, whenever we did our graph, they were those invisible dotted lines that our graph can get really, 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 really close to, but will never ever touch. Okay, and we have one at 5, and we have one at 7. Okay, so what I want to kind of note here is h gives us our vertical asymptotes, and k will give us our horizontal asymptotes. So kind of keep that in mind for that. So again, h is wherever the x is, k is just kind of out on its own. H gives us the vertical asymptotes, and k gives us those horizontal asymptotes. And again, if you figure out what asymptotes are, that's all right, but they are invisible magical lines that our graph will get really, really close to, but will never ever touch. Okay, and our graph would look something along the lines of that, because we are not negative up top. Okay, so we are in top right, bottom left of our asymptotes. So kind of keep that in mind for those types of questions. Okay, moving on to the next one. Okay, same kind of thing. Okay, but what's special here, okay, when we were doing our review game, most everyone was able to get k. K was pretty obvious. It's by itself, it's good. K is negative 5 here, okay, which means we have a horizontal asymptote there. Okay, but h is a little wonky in this case. So h is not going to be all of this. It's not 3x plus 6. What we have to do is we have to solve for h here. So we have 3x plus 6. We're going to set it equal to 0, okay? Because a vertical asymptote happens when we have division by 0. So whenever I want to figure out where my vertical asymptote is, I'm going to set this denominator equal to 0 so I can figure out where that's going to be. Okay, so I'm going to solve for x here. So minus 6, 3x equals negative 6 divided by 3. And x gives me negative 2, which means h is negative 2. Okay, so that's another reason why those signs flip, is we have to set this equal to 0 to figure out where that vertical asymptote is going to occur. Okay, so that's how we figure out h if it's not an obvious number like it was in the previous questions. Okay, so that's also where our vertical asymptote is. I'm just going to do that. Okay, so then if we were to sketch this, here's our little graph. Okay, we have a vertical asymptote at negative 2, so somewhere over here. We have a horizontal asymptote at negative 5. Now, what I want you to kind of note is we are negative up here. And if you remember on the previous problem, we had something that looked kind of like this, where we were on the top left, bottom right. Okay, but now that we are negative, we have to remember that negatives cause those reflections. Okay, so now we're going to kind of flip-flop spaces. Okay, so I'm going to be on the top on the left instead of the right, and I'm going to be on the bottom on the right. Okay, so that's what that negative causes. So kind of keep that in mind for our test. Hint, we didn't really talk about that too much during the review game, if at all. So keep that in mind. All right, so those are those questions. Again, figuring out h is down here under the denominator and k is kind of out by itself. And then the main thing is the vertical versus the horizontal asymptotes for those. All right, so that's that. Okay, so now let's get into, I don't want to say necessarily more of the algebra side of this unit, but it's more of the algebra side of this unit because it's manipulating equations and or solving equations. So simplifying equations is essentially just make it as simple as you can. So essentially it's like if I have a fraction like 4 over 8, that simplifies down to 1 over half, or 1 over 2. So that's all we're doing here. Okay, and what we do is we look at the like terms. Okay, so we have our 10 over 20. Okay, 10 divided by 20 simplifies down to 1 over 2. So that's all that simplifies down to. Okay, next I'm going to look at my x's. So I have x over 7 and x to the 5th. Okay, what I want you to know, think about this as x times x times x, 7x's. Why did I do this? Okay, but think about those are 7 x's and it's over 5 of these x's over here. Okay, and what I can do, I know that if I have something on the top and the bottom and it's multiplying by other things, I can get rid of it. So I can get rid of this x, this x, this x. Goodbye, goodbye, I don't like you. And I'm left with 2 on top. So that's where this x squared comes from. Okay, and same kind of thing with the y's, but I notice that I have more y's on the bottom than I do on the top. So when I have my final answer, my y will end up in the bottom. Okay, and I will have 3 left. Okay, so that's all we're doing when we're simplifying. We're getting down to simplest form. That's all. Okay, we're figuring out what we can cancel out, figuring out what can go away and what can stay. All right, that's that. Same kind of thing here. It's very, very similar problem, just different numbers. Again, I'm going to look at my like terms. I have my constants, my numbers. Okay, 15 over 35. Both of those are divisible by 5. I get 3 over 7. Okay, looking at my x's, I have x to the 7th and x to the 3rd. Okay, I can get rid of all 3 of the ones that are down on the bottom because I have more on top, and I will have 4 left on the top. Same kind of reasoning for the y's. Ooh, that's not a highlighter. There's the highlighter. We have y squared and y to the first down on bottom. So I can get rid of the one that's down on the bottom, and I'll be left with 1 up on top. I didn't make this fraction bar long enough, but that's okay. All right, so that's all we're doing when we're simplifying, is we're trying to get rid of things that we have too much of. Okay, so now let's go into more of, I guess, the useful side of simplification. That's when we're going to start kind of transitioning into what we do with multiplication, division, addition, subtraction, all of that good stuff. Okay, so we are more often not going to probably see something along the lines of this in different problems that we're going to be doing later on. Okay, and when we're doing these types of problems, we want to simplify both the numerator and the denominator as much as humanly possible so that we can get some nice cancellations and make our life easier in the long run. Okay, so I'm going to do it piece by piece. I'm going to start with my numerator. Okay, and looking at my numerator, I see that both of those numbers, both the 2 and the 14, are divisible by 2. So I'm going to take out a 2. And then I also see at least one x attached to both of those. I see 2 x's here, and I see 1 x here. So I can definitely take a singular x out of both of those. Okay, so I'm left with 2x squared. I took out the 2, and I took out one of my 2x's, and I'm left with just a normal x left over. When I take out the 2 of the 14, I'm left with 7, because 14 divided by 2 is 7, so I have plus 7, and I took away this single x that I had a minute ago, so I'm just left with 2x plus 7, and that's my new numerator. Okay, so let's see if we get anything nice down in the denominator. Excuse me. Okay, so looking here, this is my denominator. This is what I'm going to start using big X on. Okay, and we've been using big X a ton this unit, okay? And this is going to multiply to negative 105 and 16. And I know this was really hard to do without a calculator, but that's all right. If we did it with a calculator, we would have gotten 21 and negative 5, okay? Now, what I want to kind of mention here, we have x plus 21 and x minus 5. Okay, if you're unsure where I got the 105, it is 3 times negative 35 because this top part is A times C and then this bottom part is B. Okay, but what I want to kind of point out here is our A is not 1, our A is 3. And whenever we have something out in front of this x squared that is not a 1, meaning that it's not just a plain old x squared, we have to divide by whatever that number is and simplify as much as possible. So we're going to divide both of these factors by 3. Now 21 is simplifiable. It simplifies down to 7, so we have x plus 7. Okay, looks like we're going to have a nice cancellation there in a minute. But looking here, I can't simplify 5 over 3 into anything nicer, so I'm going to move that 3 out in front of that x. So I have 3x minus 5 as my second factor. Okay, so those are my two pieces of my numerators and my denominators. Okay, and if I notice, I see some really, really nice cancellation that's going to make my life really easy in the long run. I see an x plus 7 on the top and I see an x plus 7 on the bottom. Okay, and now I have a much simpler problem to work with. I have 2x over 3x minus 5. And that's why this idea of simplification is really, really nice for us because we can get this really nice cancellation. We can make our life a whole lot easier on these harder problems that we're about to get into. Okay, so that's what simplification is when we're dealing with stuff that looks more along the lines of this. So let's go ahead and kind of look at this type of problem. So we're going to start with division and multiplication because addition and subtraction kind of play more of a role later on. So we're going to start with division. Now, division with fractions, you always do keep, change, flip first. Even though I can see that I'm about to have some really nice cancellation right here, I want to make sure that I have performed my operation before I do any cancellation, just to make sure I stay organized and that I don't forget to actually do the flip. So I'm going to go ahead, I'm going to keep my first fraction. There we go. Change the division to multiplication and flip over that second fraction. Okay, and after I've done this, now I can start canceling things out that I see because I have now performed, I guess, quote unquote, my division. I can't forget to do that. Okay, so now I'm going to see what I can cancel out. I see that those x minus 4s that I saw earlier. Okay, but I also notice that I have an x minus 2 up here on the left side and an x minus 2 on the bottom on the right fraction. Okay, when I eventually do the multiplication here, this is going to stay on top because when I multiply fractions, I just multiply straight across and straight across. Okay, so this is going to stay on top. It's not going to switch places. And same kind of thing here. This is going to stay on bottom. So eventually we'll have the x minus 2 over the x minus 2. We'll have one on top and one on bottom. So why not just make our life easy now and cancel it out before we do the operation? Same kind of reasoning for the x plus 6. I see an x plus 6 down the bottom on the left, and I see one on the top on the right. So, again, same reasoning. Those are going to end up on top of each other, so I can get rid of them now. And I'm just left with this little bit over here, x minus 1 over x minus 9. Those are my only two pieces that didn't cancel out, and that is a much simpler problem than what we started with, right? This is nasty. It looks, blech, no. I really like this because that's just two things over one. That's easier to work with in the long run. Okay. So that's how division works. All right. Multiplication is very similar. We just don't have to do the keep, change, flip because we're not dividing. So, excuse me. With multiplication, though, especially if we are in these types of forms here, we have to simplify everything before we can start getting cancellation. I'm going to come back to this. But like up here, we see a bunch of things in parentheses, and we see a bunch of these really simple factors that gave us our nice cancellation. Okay. We have to simplify down into that form so that we can get those nice cancellations. We are not in that form right now. So we have to simplify each piece of our two fractions to make our life easier later. Okay, so I'm going to go piece by piece here. I'm going to get this guy first. Okay, so I'm going to do my big X here. Multiply to negative 10. I have a times c, so 2 times negative 5. And b is 9. So I'm multiplying to negative 10, but adding to 9. My two factors would be positive 10 and negative 1. Now, just like we had earlier, okay, we have to divide those by 2 because our a is 2. So we have x plus 10 times x minus 1. Divide both of those by 2. So I get x plus 5 because 10 divided by 2 is 5. And I bring that 2 out in front to have 2x minus 1. So that's my new top left portion of my equation. So I have this guy here, and I'm just going to kind of redraw my fraction bars here. So I have my multiplication, there's my other one. Okay, now looking down over here, okay, this one I don't have to do big X on. I don't have 3 terms. I don't have a C value. I don't have to worry about any of that. Okay, but I notice that both of those terms are divisible by 2, and both of them have an X attached to them. So I'm going to take out a 2, and I'm going to take out an X from both of them. That's, so I'm left with 4 divided by 2 is 2. X squared. I took away one of the 2 x's there, and I have an x. And I took away all of that 2x on that second term, so I'm going to have minus 1 there. And I notice that I'm probably going to have some nice cancellation here in just a minute. But I'm going to simplify everything first just to make sure I don't get lost and I don't get ahead of myself. Okay, so if I notice that top right-hand portion of my fraction, I can't simplify that by anything. There's no x squareds that I need to get rid of. There's no big X that I need to do. So this is just going to stay 3x plus 2. I can't do nothing to that. Okay, so now I'm going to move on to my last piece, which is this guy down here. Okay, this guy is just big X again. So we'll have multiply to negative 20, add to 1. We will have positive 5, negative 4. So you'll have x plus 5, x minus 4. Okay, so now we are in that form that we had when we were doing those division problem a minute ago. Okay, we're in all of those sets of parentheses. We have all of these nice factors. Let's see if we can get some cancellation to make our life easier. Okay, I notice that I have a 2x minus 1 here on the first fraction. I also notice that I have an x plus 5 up here and an x plus 5 down here. So both of those can cancel because eventually they'll end up on top of each other. Okay, so what I'm left with in my numerator is just my 3x plus 2 divided by, I have that 2x still out there. Then I have the x minus 4. Again, I'm just taking the pieces that I had left over that didn't end up canceling out and kind of just shoving them together. Okay, so that's it. That's what my equation simplified down to, which is much nicer than what we started with. Okay, so that's that. All right, let's see. Okay, so division again, we always do keep, change, flip first. Okay, even if we want to simplify and do the big X and all of that good stuff, we have to do the keep, change, flip first just to make sure we don't forget to do it. Okay, so now that we've done that, now I'm going to simplify some stuff. I'm going to do my big X over here on that lovely guy. So we have negative 15 and 2. So I'm going to multiply to negative 15, but add to 2. We have positive 5 and negative 3. So we will have x plus 5, x minus 3, divided by x cubed times my 5x over x minus 3. Because I can't do anything else to this guy over here or this guy. Those are as simple as they're going to get. Okay, so now I'm going to look for those cancellations that I hopefully will have. I see the x minus 3's. Okay, but a lot of y'all kind of struggled with seeing, I'm going to zoom in just a little bit. A lot of y'all kind of struggled with this. So many of y'all during our games were able to get here, which is great. This is partial credit. That's good. Okay. But what I want you to be able to recognize is I see an X up here by itself, and I see 3 X's down here. Okay. I can get rid of this singular X right here, and I can get rid of one of my 3 X's down here. So I'm left with my 5 times X plus 5. That didn't change. Divided by now x squared, because I took away this top x from both of these. So I took away one of these 3 x's and I'm left with 2. Okay, a lot of y'all were not able to see that right away, which is just fine. You're still learning, but that's what that means. Okay, so if I see something like this, I'm able to cancel that out. Okay, so keep that in mind. All right. Okay, so now that was division and multiplication. So let's talk about, let's kind of ease into subtraction and addition. Okay, so when we're doing subtraction, addition, and then later on when we're solving, we have to have these common denominators. Okay, so again, a common denominator is where we are able to have our denominators look exactly the same so that we can combine their numerators. Okay, so looking down here, when we're trying to find common denominators, what I want to do more often than not is I just want to focus on my denominator, okay, because I'm trying to find a common denominator, okay? So I'm going to look at the denominator here, and I'm going to see if I get something nice that looks similar to this other one, because that would be really, really cool. So I have a 14 and a 9. I want to multiply to 14 and add to 9, so 7 and 2. So now my fraction, I'm not going to big X that top part just yet. And divided by x plus 7 and x minus 2, okay? What I notice is I also have an x plus 7 over here, but let's say I were to perform the subtraction here, I would have to multiply the 8 by the x minus 2, okay? Because now I'm able to do the subtraction, because again, to add and subtract fractions, I need common denominators, and now my denominators look the same, which is great. Okay, so now I can perform that subtraction. Okay, what I don't want you to do, I saw a lot of people doing this during the games. Don't just do that. Don't cancel out. Don't do that. Okay, that is undoing all of the work that we just did. That is undoing the big X that we just did. We now can't perform the subtraction if we do that. So don't do that. Okay, don't simplify. Don't cross out until the very, very end when you're doing addition and subtraction here. Okay, so I'm going to have my x squared plus x minus 6 minus 8x plus 16. I'm just distributing that 8 in there. And then I have my common denominator of x plus 7 and x minus 2. And from there, you would simplify and all the good things. So you could big X this once you combine like terms and all that good thing. For that, I don't think this one works out as nicely. I think I realized that during one of my games. So that one doesn't work out as nicely. But again, simplify after you have done the subtraction or the addition. Do not try and cancel things out beforehand, because that's undoing work. That's making your life harder in the long run. Okay? So that's that. Okay, same kind of thing here. I'm just looking for my common denominator. Okay, if I notice though, both of these are in simplest form already, which is great. Less work for me. Okay, so my common denominator here would be x times x minus 1. I'm just taking the two pieces of my other two denominators. Now, the thing that's a little tricky about this one, okay, this is a whole number. Remember that whole numbers can be written as something over 1. Okay, so when I'm trying to get that 4 to have a common denominator of x times x minus 1, I have to multiply it by both of the pieces that I'm missing. So I have 4x times x minus 1 minus the 6 is missing the x. It has the x minus 1, which is great, but I don't have this x that I need. And I'm equal to 3 times x minus 1, because again, similar reasoning from the 6. I have the x, I need the x minus 1. So that's how we would kind of do that one, and that one kind of shifts into what we're about to do in solving. Okay, but then you would solve for x and all of that good stuff, which we'll talk about here in a minute. Okay, but that's what I mean by these common denominators. I'm just taking all of the pieces of all of my denominators that I see on my fractions and kind of shoving them together and multiplying. Okay, that's that. All right, so now let's actually perform an operation that will work out nicely because the other one didn't. Okay, but we want to find our common denominator first, which means we got to simplify everything first. So I want to multiply to 15, add to 8. Okay, so 5 and 3. So I'm going to have my first fraction didn't change, so I have 1 over x plus 3 plus 3 over x plus 5, x plus 3. And if I notice, I have something in common here. Okay, so my full common denominator is this piece right here. I have the x plus 3 on both of them, but this first fraction needs that x plus 5 before I can start performing that addition. So I have 1 times x plus 5 all over. Now I have my full common denominator on my left side plus 3. I don't have to do anything to the 3 because the 3 already has both pieces of our common denominator. I don't got to do nothing to it. Yay, less work. Okay, so now I have x plus 5 plus 3. All of that is over my common denominator of x plus 5, x plus 3. Combine like terms, x plus 8 over x plus 5, x plus 3. That is what I mean by I want you to simplify the numerators fully before you do any cancellation, because if we look here, we don't have anything we can cancel here. I don't want to do cancellation prematurely. I don't want to say, hey, I can do that. I see a top and a bottom. No, because now we've undone the work that we just did. Okay, we want those common denominators to be there. We want to multiply the numerators by other things so that we can perform that addition or subtraction. So don't simplify, don't cancel anything out until the very, very end of your problems. Okay, so that's that one. So now let's get into solving. So we talked about solving in two different types of problems. We had this first type of problem where we just had two different fractions on either side of the equal sign, and we get to two methods. We could use the common denominator method, which we'll use on the other problems, or we could just cross multiply, and that's what I'm going to do here because we're going to see the other method here in just a minute. Okay, but we can cross multiply with these types of problems. Again, this only works for this type of problem where I have one equal sign and two fractions. Okay, if I've got, and later on in the problems, I've got two other fractions over here is equal to one fraction, I can't cross multiply, don't try to do it. Okay, I can only cross multiply if I have two fractions on either side of the equal sign. Okay, so I'm going to do that. I'm going to have x times x minus 9 is equal to my 7 times x minus 4. And from there, I just kind of distribute x's, distribute my 7. So I'm going to have x squared minus 9x equals 7x minus 28. Okay, now from here, I see an x squared thing, and I usually want something that has an x squared and some stuff equal to some sort of 0 so that I can do big X eventually. Okay, so I'm going to subtract the 7x and add the 28 to both sides. So now I have x squared minus 9 plus 7 is what, 16? Yeah, 16x plus 28 is equal to 0, which is what I wanted because now I'm able to perform the big X. Okay, so I'm going to do my big X, multiply to 28, add to negative 16, negative 14, negative 2. So now I have x minus 14, x minus 2. So I get x is equal to positive 14 because again, we are solving for x in this problem, and x is equal to positive 2. Now, with these types of problems, you always have to check your answer. Okay, so I'm going to do that real quick. So I have 14 over 14 minus 4 will hopefully equal 7 over 14 minus 9. So 14 over 10 equals 7 over, what is it? What's 14 minus 9? 14 minus 9 is 5. Yeah. And if I look, this first fraction can divide by 2, and I can simplify that down to 7 over 5, which equals my 7 over 5. So my 14 works. Yay! Okay, so now let's check the 2. Okay, so we'll have 2, I'll do it over here. 2 over 2 minus 4 equals 7 over 2 minus 9. So 2 over, negative 2 equals 7 over negative 7. So that gives me negative 1 equals negative 1, which is good to go as well. So both of my answers are good. Okay, if you forgot, let's say I got something like 5 is equal to 6. 5 doesn't equal 6, then one of our answers would be extraneous, or if we got an error when we plugged it in the calculator, meaning we had division by 0, then that solution would be extraneous. Okay, I don't think we had any extraneous solutions with any of these problems for this, but keep that in mind. All right, so that's that. Okay, so now let's talk about this other case. So this other case where we have more than 2 fractions, we need that common denominator, okay? And again, I have to find out what this guy is so I can see if I get a nice common denominator, okay? So I'm going to do big X on this guy. I'm going to multiply to negative 10, add to negative 3, negative 5, positive 2. So I notice, ooh, I have x minus 5 over here plus 2 over x plus 2 equals 11 over, I now have the 2 pieces for my other side of my equation, which is great. That's really nice. Okay, sometimes they're not as nice to you, but more often than not, they will be. So that's that. Okay, but what I need to do now is I need to multiply my numerators by the pieces that my denominator is missing. So my x over here is missing the x plus 2. I have the x minus 5, which is great, but I need the x plus 2. So I have x times x plus 2 plus 2 times the x minus 5, because similar reasoning, I have the x plus 2, but I need the x minus 5 to be able to have that common denominator. Now the 11, I don't got to do nothing to, because it already has both pieces. It's not missing anything. It's doing great. Okay, so I don't have to do anything with that guy. So now what I'm going to do is I'm going to just solve for x like we have been doing. I'm going to have x squared plus 2x plus 2x minus 10 equals 11. Combine like terms, we get x squared plus 4x minus 21 equals 0, because I'm going to subtract 11 from both sides. Now from here I do big X, negative 21, positive 4, we get negative 3, positive 7. So we have x minus 3, x plus 7. So that means x is equal to positive 3, x is equal to negative 7. Okay, and then you would plug those in and check your answers from there. But those will work. I'm going to spoil it. Okay, so those work. And you would just plug them in again wherever you see an X. Okay, so that's that. I think that's it. Yeah. So per usual, please like and subscribe to my YouTube channel, because I have a whole like 6 followers or 6 subscribers or whatever they're called. So I would love more, because yeah, that'd be cool. But please like and subscribe to my YouTube channel, and please watch out for the next video. If you have any questions, please let me know. Email me, all the good things, and I will see y'all later. Bye bye.